All right, hopefully you enjoyed your break and welcome back. It is time for another one of our talks. And joining me for the third talk of the day, I've got Lucas to talk us through delivering apps at scale. Take it away, Lucas.
Thank you very much. Hello, my name is Łukasz, and today I will share some findings and learnings from my basically daily work. When I do exactly this, I work with a team that manages apps at scale. So let me just switch the view. I hope everything works just fine, and we can take it off. So daily, I work as a Kubernetes platform architect at a Giant Swarm. Giant Swarm is a company that basically manages Kubernetes clusters for our customers. And I work with a team that is responsible for preparing tools that make it possible to deliver apps to hundreds of clusters and not get crazy in the process. Today is a problem, and I'll spend some time showing you how, and obviously a short summary at the end. Let's start with problems that we have. Well, main problem is preparing applications to run on a Kubernetes cluster. This obviously involves some very basic stuff like how to prepare, how to package your app so it is ready for delivery. How do you ensure your best practices? How do you make sure that what you deliver is of a decent quality? How do you make sure that what you deliver actually runs? So sure, you can deploy, but will it run? And then some more stuff, how to manage lifecycle. For example, you want to do an upgrade, how to do that. How do you manage configuration? Because basically when you manage apps at scale, some patterns emerge, some best standards, some company practices. You want to be able to share that across multiple apps, yet you still want to do some last mile tuning because, for example, a dev cluster will use a smaller instance of your app than the production cluster. So how do you do that? Well, fortunately, we have Helm. You probably heard about Helm, but just as a very general and short introduction, Helm is like a package manager for Kubernetes. So what Helm does, it allows you to take all the resources, all the manifests that describe what is needed to create your application. So like a deployment object or a service object, ingress object, basically anything, and pack them together into a single archive. And then using Helm, you can deploy this archive to a cluster of choice. Additionally, Helm allows you to template some of that, so you can you can fill in some parameters. The most important part, you can let your users to fill in some parameters. So it is configurable by the package developer, but also by the package user. So that's pretty neat, right? And a short terminology about Helm, because they use a few words on their own and it's good to know them because I have to reference them. So chart is the package. Like I said, Helm is a package manager. A single package is called a chart. A repository is a service that is exposing multiple charts. So basically, it's like a web page that hosts your charts and Helm can download charts from there. And finally, release is a configured chart that is configured. That's the first thing, but also installed on a Kubernetes cluster. So once you have a configuration and you do the deployment, the actual deployment is called a release. And that's it, right? I can go home now. I mean, maybe it was short, but at least we have a solution, right? Helm, the package manager, solves all the issues. Still, this starts to be a problem when you want to do this, not for a single cluster, not for 2 or 3 clusters, but as we do, you want to do that for hundreds of clusters at the same time and have control and have visibility. And in general, more problems. Because when you have hundreds of clusters, you have more problems and different problems, and some shortcomings of Helm show up. So first of all, Helm is a single cluster targeting utility. There is no way you can use Helm to deploy to multiple clusters or coordinate deployment across multiple clusters at the same time with Helm. Next thing is preparing a chart should involve some testing, right? You should make sure that what you want to do in production will work. but Helm is also pretty limited to only installation time tests in this regard. Next thing, everything we do at Giant Swarm, we try to make it Kubernetes native. So we try to have Kubernetes native API that drives this thing. Unfortunately for Helm, there is no representation in Kubernetes API at all. Helm basically allows you to do also one configuration layer. So what I mentioned, that usually you want to provide same defaults, but maybe then there are like company defaults, and still there may be some options that are per cluster specific. It's really hard to orchestrate this when you use plain Helm. Helm is also well known for having some more specific issues like CRD management, like cluster like lifecycle management. And obviously, because this works mostly as a client server, let's say, approach, where your Helm CLI is like a client and the Kubernetes cluster you target is like a server, this has some problem that the command that was used to deploy a specific application exists only at the laptop of someone who executed the command. And this can become a problem as well. So what solution have we came up with? Our solution, we name it App Platform. So what can it do? First of all, why? Which problems out of these that I mentioned we want to address, because we won't solve all of them. But first of all, with App Platform, we try to target the Kubernetes application release problem from the very beginning. So we want to ensure some quality, some repeatable process already at chart build time. Then we want to make sure that what we deliver to our customers, so what we deliver to clusters, is tested. So we want to have some testing framework, and only then we will think about lifecycle problems that this problem involves. This means that we will focus on how to share, reuse, and override configuration, how to manage lifecycle across multiple clusters, and how to have a representation of what you do with Helm at the Kubernetes API level in a, let's say, cluster API style, which means that you will have a single control point from which you can control your whole fleet and all the apps that go to your fleet using Kubernetes native API. So what is inside App Platform? This is a set of tools, and basically we have four main types of tools. First one is used to create apps. This is the app build suite part of it, which handles the build process, executes some and enforces some best practices, and provides some additional metadata that I will get back to. Next step is the testing pipeline. So we make sure that, yes, it builds, but does it run? This is the app test suite part. Then we need a storage. When a chart is built, tested, it is not yet delivered anywhere. We need to put it into a repository. So this is the third part, repositories. And finally, last but definitely not least, and the biggest part of it, is our operators that run on Kubernetes clusters and manage the deployment and configuration of multiple charts into many clusters at the same time. So trying to show this in a more graphical way, going from left top, you can see that we start with application developer. By application developer, I mean here Helm chart developer, who checks sources and passes them through app build suite that builds a Helm chart, runs linters, checks for best practices, some other stuff, generates basically two stuff, Helm charts and metadata. Metadata is an extension that we introduced in our build pipeline because, as you probably know, inside your Helm chart, in the chart YAML file, you can already provide some metadata. For example, Kubernetes API version that this chart is compatible with. But we want more. We want to make our charts more resilient and easier to use for our customers. An example, some charts, let's say network meshes, they can be installed only once per cluster. Or some charts that include a lot of CRDs, they can usually also be installed only once per cluster. Otherwise, at the second installation attempt, you will get a conflict. To avoid this conflict and to avoid this unnecessary frustration of a potential user, we are introducing additional metadata that can say, for example, this chart can be installed only once per cluster. And this is already generated at this point and enforced later by our operators when you try to deploy the same chart for a second time on the same cluster. Once we're done with the build step and we have build artifacts, so chart and metadata, we include more stuff from our side, some application developer side, which are tests. And we put all of that into uptest suite. So it takes a chart that was built, it runs the tests, uses for that a test Kubernetes cluster where those tests can execute. So these are end-to-end runtime tests. They can test for functionality and what the application really does, or roughly should be doing. And again, part of that we save to our metadata. So for example, we can save to metadata information that we did an upgrade test of our application from version X to version X+1, and this upgrade test was successful. So later, when a user wants to follow the same upgrade path, it is already tested, and user gets a confirmation that yes, your upgrade path is safe and you can safely execute it. When all of this is done, so we have metadata and we have Helm chart and the chart is tested, we put it into a Helm repository. Then we have the main part. In general, our architecture always assumes that you have two types of clusters. One is a single management cluster, and this cluster takes care of managing, creating of workload clusters, multiple workload clusters. And the same way it manages the creation of clusters themselves, it also manages deployment of applications to all of those clusters. So on management cluster, we have a set of operators that constantly scan the Helm repository, detect what's there, what charts are available, what metadata do they have, says that on the Kubernetes API level, and from there takes intent, takes specific operations from the fleet manager, the fleet administrator, and uses that to deploy your app with indicated configuration to a workload cluster. Now, this is like 10,000 meters view, right? It covers everything from building the chart to running a chart in a workload cluster. Now, I will try to zoom in a little bit and tell you a bit more about each of the four main parts of this workflow, focusing specifically on the operational part, right? So first thing, sure, you can just build a chart, and it will probably be a great chart unless you forget about something, right? So first thing we want to focus on is best practices and a defined, let's say, pipeline that you can use to build your chart. For that purpose, we have created a actually really simple tool, App Build Suite, that runs our opinionated and repeatable process that, and this is important property for us to shorten the dev feedback cycle, that can be run on CI/CD to build and store your charts, but also can be run exactly the same way on your local machine. So basically, even before you push to a Git repository and before CI/CD kicks in, you can already run the same process and quickly check the results on your own machine. And basically, an overview of what it does is that it sets some additional properties in chart YAML. For example, detects version that is available in Git and sets inside the chart YAML file, runs some external linters, code quality tools that we find useful, and then executes Helm. So basically, we haven't created much logic there. We are reusing what open source community already has. We just invoke those tools with predefined configuration in a defined sequence, and that's it. At the end, what we get is a Helm chart archive and our additional extended metadata file. And as I mentioned, in the metadata file, we put everything that is non-standard metadata, because Helm already has some standard metadata properties, and save it as an external file. The important part is that if you remove this additional extended metadata file, what you are left with is 100% Helm chart. So we are not violating Helm specification anywhere. Everything we do is like 100% Helm compatible, and at any point you can always quit on extensions that we built, and you will be left with plain old, if you can say that, Helm chart and Helm deployments. So this is the build process. Next step, obviously testing, right? I know like real users, real admins, real DevOps test on production, because what's the point of testing in artificial test environments when you can test in production with your real users? Still, if you disagree with this approach, let's have a look why and how we have introduced the uptest suite. So uptest suite is the next step in our application preparation pipeline. Again, this is a repeatable process, repeatable tool that runs an opinionated pipeline of what to do and where, and it is intended to run on both dev machines and CI/CD. They're exactly the same tool, because our point over here is also to shorten the development cycle, so that before you push to CI/CD, before you wait for CI/CD, you can already have the result on your local machine. What uptest suite does is it executes what we call scenarios, test scenarios. Each test scenario invokes some class of tests. So currently our tool supports smoke, functional, and upgrade tests. And I think it is like pretty intuitive to understand what they do. Smoke tests should test very basic stuff, but fail fast, be able to fail fast. So if a smoke test doesn't pass, there's no point in executing the rest of tests that can be more complex and may require much more resources and much more time to execute. Then, if smoke tests pass, it executes functional tests, which checks basically, does my app work? Like, there's a Kubernetes cluster, there's the chart that I've built. Now, does this chart deploy my application correctly? Does it work? So we execute functional tests that check if the application is not only deployed, but it really works. And then we can also execute upgrade tests that I already mentioned before, that check if, assuming my application is in version X, and now I'm preparing a next version of my application, and then customer goes this upgrade path, does it work? Like, maybe something will break, maybe some API changed or something. Let's make sure. What this tool does as well is it takes care of preparing your cluster that you're going to use for testing. So there's a set of tools that is needed to actually make this work. Like, for example, you need to upload your chart somewhere so that later it can be available for all the operators. So it takes care of that, so you don't have to. We currently support writing tests in two languages. This is Python and Golang. So whichever of these two suits you, you can pick one. And the whole smart part of uptest suite is that it separates actually test scenarios from test implementation itself. So you, as a application developer, you only deliver implementation of tests, and you mark your test appropriately, and then the rest, how the scenario looks like, what needs to be done for the scenario, and so on, is not your problem. This will be executed and taken care of by uptest suite. And like I think already mentioned, that you can use uptest suite to produce some additional metadata, for example, with information about the tested upgrade path. A more graphical example. On the left side is execution pipeline of uptest suite tool. On the right side is a stub for a Python set of tests that application developer needs to deliver in order to make it work. Okay, so on the right side we have three test cases, three test methods. Each of them gets as an input information about the cluster that it runs on. So you can check the cluster apps that are there. You get basically full API access to this cluster. And now we marked our three tests as The first one as smoke, the second one as functional but also upgrade, and the third one as upgrade only. And that's it. Like, you only declaratively say, please run this test as part of functional scenario or upgrade scenario. And now uptest suite takes care of executing them in the right order. So for example, smoke and functional scenarios are very simple. They just mean, out of all the tests, find those that are marked as smoke or as functional and execute them in a single go. Okay. But for example, upgrade scenario is more complex because we first take the last stable release of your chart. We execute all the tests that are marked as upgrade. They should basically test for application functionality as well. That's why it is pretty common to see a method, a test case that is both functional and upgrade, because it tests some functionality of your app. And this functionality should be also working before an upgrade and after the upgrade, right? That's pretty natural. So the upgrade scenario executes everything that is marked upgrade, but on a chart that is not the one that you're building, but the one that is the latest stable, then does the upgrade of your app, and then executes all the upgrade tests again to make sure that what you want to be working works also after the upgrade. To make it even easier, we have created additional project. This is really just a short mention. That is a PyTest plugin. We call it PyTest Helm Charts, that has some helper methods that will make it easier for you to access Kubernetes API server, query API server, work with it and on it. If you're interested in writing those tests, have a look at it. Next part, you need to store the chart somewhere. So we're focusing now on this right side of the 10,000 meters view, which is a Helm repository. To be honest, currently, this is the part that we want to work on. We have a big roadmap for it, but right now we keep it really, really simple, as we are exposing our Helm charts either through HTTPS as a plain web server, and we expose there our charts and metadata, or this is the process that we started to work on really, really recently. We try to use CRI registries to store the charts. But so far, that's it. We have some, like I said, more advanced scenarios, but this part so far we keep really simple. So the next part is time to deploy an app. Like, we have chart built, tested, stored. Well, now it's the lifecycle management. The problem is that one does not simply install an app in Kubernetes. Why? Because there are multiple tasks and events involved into this management into this lifecycle management thing. You need to manage configuration. You need to be able to see the status of your apps. You need to monitor them. You probably need some configuration, and so on and so forth. All the problems that I listed to you at the beginning of my talk. So to make it easier, we have created some operators that run, like I said, on management cluster and on workload clusters. And these operators act on our custom resources. So we have created some CRs by providing CRDs in Kubernetes, right? And they describe whatever you need. And starting from the top, we have two CRs. One of them is called catalog CR, and the other is called app catalog entry CR. The purpose of those CRs is to reflect and show in Kubernetes API, in Kubernetes native way, what do you have available? I mean, which apps do you have available? Which versions? Which catalogs? Because you can have multiple catalogs. So we call a catalog what is basically a Helm registry. So you can create multiple catalog CRs in your Kubernetes management cluster. They point to different Helm registries. Then our operator goes there, can scan them, and create app catalog entry. App catalog entry CR, or entries actually, one is created per each application, so chart release version that is available in the catalog. So we save this as an API object as well, so you can get native Kubernetes access. And then when you know what is available, you can create an application CR, that for short we call just app CR. So AppCR is your intent of a user to get a chart, give it configuration, and install it on a target workload cluster. And all of that is available on your management cluster. So you get like a single pane of glass view of what is going on, what is going to install, to be installed where, and so on. And finally, we have one more CR that is not really user-facing, but it is a bits and bolts part of the solution, that is called chart CR. And this chart CR is created already on the workload cluster, and it shows over there what was the original intent created on the management cluster to deploy an application on this specific workload cluster. So to act on those CRs, you need operators, right, in the Kubernetes world. And those Kubernetes operators are our main software components. The first and probably the most important one, as it actually does configuration management and lifecycle management, is what we call app operator. So app operator watches catalog CRs. As I already mentioned, they basically answer the question, where is the catalog? So where are your charts stored? Then watches them and creates app catalog entries CRs, which say what is in the catalog, which apps, which version. But it also scans for this additional metadata. So it can already save information in app catalog entry CRs about, for example, in restrictions like this app can be installed only once on a target workload cluster. Then, to make our configuration easier, a problem that I started with is that you usually want to have like more complex configuration schemes. So to make it easier for our users, App Operator supports 3-level config merge. So there's like a top level, what we call installation level configuration. So something that is common for really all the clusters, workload as well as management clusters. Then there is a second level, which is like a default administrator's config for this application. So, for example, if you're a part of a platform team, you can put your configuration at this level. And then we still leave one level of configuration for end users, because maybe your end users, they need to tune something, change something. So we have this like 3 levels of available configuration options, and then they are merged. So the lower the configuration level is, the higher the priority. So it overrides all the previous ones. As a result of this merging of configuration and checking stuff between catalog, app catalog entry, and the app CR, so what should be installed, how it should be configured, and where it should go, as a result, a chart CR is created on a target workload cluster. And over there, another operator takes over. This is the chart operator. We need to have chart operator on each of the workload clusters. And over there, it watches for chart CRs that are created by the app operator on the management cluster. And this is basically a gist of everything that operator did. So it has a merge configuration information about what should be installed, and this needs to be installed locally. And chart operator makes sure that this is installed locally using plain Helm. So even if you will like, you or someone by mistake, by a random chance, will remove a Helm release from this cluster, chart operator is there to constantly reconcile the state, and it will recreate the Helm release, it will configure this Helm release, and you will be back in a good shape. Besides these two main operators, we have some helpers that are actually operators as well, but we usually call them something simpler because they have very, very narrow scope. First one is App Admission Controller. This one runs on MC, so on management cluster, and does validation and admission of app CRs. What does it mean? I mentioned a few times already that with your application, so with your chart, you can also provide some additional metadata that, for example, forbid installation twice on the same cluster. At some point, we also want to have these restrictions enforced, right? And that's why we have App Admission Controller. It can parse additional metadata, and it is basically a guardian that helps us keep our users from doing stuff that will basically hurt them. And the last component that we run on the management cluster is what we call App Exporter. this thing just watches all the app CRs created on the whole management cluster. And from there, it creates Prometheus metrics, so we can easily watch like what we have running, what is the state of all the app CR objects, and so on. So it gives us a great overview of the whole control plane, of the whole management cluster, showing us what do we actually have there and what is the status, versions, and all of that, okay? So you basically hook it up to your Prometheus. From there, we have a Grafana dashboard, and this is our monitoring part of the deployment and lifecycle management part of App Platform. I know that that was a lot, at least to describe and talk about. So now to try and make it easier for you, I have prepared a graphical part where I can show you this process, this lifecycle management process, step by step. So I hope it will be even easier to understand. So let's start with just a management cluster. We have a single designated namespace there. And in this designated namespace, the tools that I just mentioned, the 4 software components, run. Now, here comes a user. A user creates a dedicated namespace for him or herself, and then uses some tool to basically like kubectl normally, right? But this can be anything, obviously, that can interact with API server on Kubernetes to talk with our app operator. And the first step that needs to be done is to create a catalog CR. Catalog points to a repository, Helm charts repository. So basically it tells us from where we can install applications using app operator. Once app operator goes there, goes to the catalog, scans the content, scans what's available inside, and creates app catalog entries, which once again show you application and application version as the very minimum information that has to be present. From there, you can already use your kubectl command to figure out what is available in your catalog. So you can do kubectl get catalog and check which catalogs are available. You can do kubectl get ACE, and you can check which applications are available in the catalog and which versions do you have, because you want to install them somewhere. And to install them somewhere, you create another object in the Kubernetes API server, which is called appcr. And appcr connects information about application to deploy that is visible in a catalog, configuration that you need to prepare in the form of config maps and secrets with this availability of 3-layer merge that I mentioned previously. And then obviously you need to target a cluster. So you need to provide a workload cluster for it so it can be deployed there. As a result, app operator will connect to your target workload cluster, and again in a dedicated namespace where chat operator runs, and it has to be running there previously. So that provisioning of chat operator needs to be part of your cluster provisioning. It creates a chart CR, and this chart CR has already everything embedded, information about configuration, application, version, namespace to deploy to, and so on. Everything that we need to actually invoke Helm and ask Helm to create a Helm release. And from this Helm release, you go, well, Helm goes and does everything for you. So it deploys the package, deploys the chart, creating your deployment service and whatever else you have in your Helm chart. Obviously, this scenario shows just one cluster, but if you have multiple clusters, you do this again. You just create a different namespace, and in this namespace, everything is working exactly the same. You get a dedicated app operator for your target cluster. This app operator watches namespace restricted resources. So if you have a multi-tenant cluster, this still works. You can have different set of catalogs in one namespace and different set of catalogs and apps and ACEs in a different namespace. Because, for example, you're a platform team and the clusters that you are targeting are owned by different teams within your company or different end users in general. So you can separate all of that with RBAC, basically. And so on and so forth. As many clusters as you have, everything you can control from a central point of view, central control plane, which we call management cluster. You don't touch the workload clusters at all. Now, wait, there's also one problem. Like, what if part of this configuration is available only on someone's laptop, but this laptop is gone because your colleague is on vacations or something? Well, we make it already a little bit better because everything, like the whole information, is available on the management cluster. The config maps that include the configuration, they are there. Information about which app should be deployed where, they are there. Still, if someone by mistake deletes one of them and the person that created them is not available and you don't have that, well, you probably see where I'm going with that. We have a really high high level of GitOps interest right now, right? People are talking GitOps, and yesterday we had a GitOps future of GitOps panel. And GitOps for us is essential integration. It's not mandatory, you can live without, but I think this is really essential part of what we do and how we think this should be working. So the question that we often get is, okay, great, but can I integrate what you did with a GitOps solution? And the answer is yes, naturally, because now everything that you do to configure, to deploy, and deliver your applications at scale for a fleet of clusters is enough to configure that and make it available on a single management cluster. So you only have a single control point you need to set up for your GitOps operations. But even more, everything is now represented as a proper Kubernetes API objects, right? So no problem to use it with GitOps. Just save them as YAMLs, our app CRs, catalog CRs, and config maps and secrets. Put it into a repository, and you're done. You can already have GitOps, and with that you get a bunch of benefits, right? You have history, you have audit, you have pull request. So in general, this is the workflow we actually encourage. Like, if you want to get the best experience, we recommend actually Flux as a GitOps tool. This is also what we do internally for our customers at the company. And that way, you also extend the app platform features with GitOps, which, in my opinion, is really, really great to see and use together. Okay, with that, I am ending my journey. I took you through this whole slide from building a chart, testing a chart, storing, and then doing lifecycle management. And we even mentioned something that is dear to my heart and important in lifecycle management, which is GitOps. So yes, everything is awesome. Obviously, awesome to some extent. Like, have we solved all of the problems? No. There's stuff burning here and there, obviously. And no, we haven't solved all the issues that are possible when you manage applications at scale, but we are still happy with it. So once again, in our company, we needed to deliver apps to hundreds of clusters. Right now, we manage over 200 clusters for our customers. We wanted to use the open source approach, and the obvious choice was Helm. The problem is that Helm is not really made to be used as a tool to manage apps at scale. It's more a packager or package management tools. So we tried to extend Helm while still being 100% Helm compatible to get our app developers, so people that provide apps for our customers at our company, help them from the build stage through testing stage to deployment stage. So it is easier for them to work with Helm and to provide our developers, but also our customers, a Kubernetes native API where they can check what is available as an app, and a KEPI-like central control point where they can orchestrate their whole fleet of clusters from a single control point, right? Obviously, the important part over here here that I want to mention is that we are again standing on arms of giants, right? We built all of that, but we are using dozens of open source projects underneath. Flux, Helm, other tools, really. This is all feels like a glue layer that makes it all work better. And like I said, we are not done yet, right? I completely skipped a topic of delivery pipeline security, something that is really important right now. And yes, we have this on our roadmap, but haven't started yet, unfortunately. And we would like to really incorporate something like six-store support at every stage of this build and delivery and management pipeline. And also, we want to extend our metadata experience for our customers, our users. So, for example, we want to include like real runtime dependencies, or we want to do a real compatibility checking. So we don't only declare that something will run on a specific Kubernetes version, we really want to test this. So we want to run tests across multiple versions of Kubernetes and add this information to metadata. And in general, we can add a lot to metadata to make application management at scale easier for our customers. So thank you very much for spending time with me over here. It was a pleasure for me to be at this conference. The only drawback is that I couldn't see and meet all of you in person, but still you can ask questions. If you have any, please just ask and I will do my best to answer them. Thank you once again.
Thank you, Lucas. Definitely an interesting talk. I guess I'll open it up while we wait for some people to throw through Q&A questions. If you've got questions, remember there's a tab. You can go in it now. You can type out your questions, and then I'll field them across to Lucas. But one thing I thought maybe while we've got a chance to kind of glaze over a bit more is you mentioned, obviously there's only so much you can cover. There are other things in the pipeline, things that you're working on, and you admit yourself, we're not solving every single problem right now, but clearly there's an intent to solve additional problems down the line. What are the biggest things you're looking to develop as you move forward here? What are the biggest problems you're looking to solve that haven't been ticked yet?
I think these are exactly the two things that I showed on the summer slide. First
Okay.
one is delivery pipeline security. This is like the number of delivery pipeline attacks is growing really wild right now, right?
Yeah.
So there's a lot of effort both in, let's say, Helm and Flags that is going on right now to ensure that the delivery is safe. The whole effort by Sigstore, tools like Cosign, and basically adding digital signatures to everything. This is a clear trend. And for example, this year in KubeCon, there were a lot of talks about them. And we want to follow as well. Like we know that basically the major tools that we use in our solution will have them. So we want to extend and actually just enable our tool to use them. That's it. That's one focus area. Second, as I mentioned, you can think about really many and multiple use cases where we can save something to our metadata, extended metadata file, so that it is like the user experience is better. It is harder for user to misconfigure the application or basically create a problem for himself because of limited information about how this application actually works.
Hmm. And do you like with those two problems you're trying to tackle? Do you have like a clear um, idea of how you're going to solve those? Is there a timeline for the app actually solving those issues, or is it kind of as you go as it stands right now?
It's more as you go kind, because like I can't really give you any specific dates. I can tell you that, for example, the upgrade testing that I mentioned here, it is already it's not 100% finished, but for example, this kind of test is already supported in the uptest suite, and it is available in the metadata files. It is not yet enforced by app admission controller. So we want to have obviously some logic there that if a user edits appcr object and says, okay, I had my application in version X, and now I want this in version X plus one, but there is a test result that says this won't work. Your app will fail if you do this upgrade. We would like actually the user to block it, uh, unless there's, let's say, a force option where a user says, okay, I know better, because sure, that's an option as well, right? So this is the state where we are at now. So we are working on a better user experience and better usage of metadata and upgrade testing, but we have really multiple ideas about how we can extend this metadata to make the user experience even better.
Okay. I like that answer. It seems like you kind of got your head screwed on. And it's going to be a long process through which you're iterating. So look forward to seeing how this can develop further. And for anyone who wants to try out the product, where can they get it?
Um, Obviously, slides are available on when I was introducing every single slide, every single tool, sorry, on
Yeah.
the slide. There's a URL. Everything is public on GitHub. All of that is open source projects, projects that we did, projects that we use. All of that is open source. So just follow the slides, follow the URLs, and you will find all the tools that I was talking about.
All right, fantastic. Well, thank you, Lucas. We won't take up any more time. It has been a pleasure to listen to you, but we've got to move on to our next talk. Up next, folks, we're going to have serverless containers with Azure, containers, instances, and apps. So stay tuned. In a few minutes, we'll begin the next talk.